Hello everybody, it is time to look at the 4-5 worksheet about congruence in right triangles. Trying to knock out a whole bunch of worksheets in one day, and this is the 5th video I've recorded this morning. So they're getting to be a little bit repetitive, and hopefully it doesn't come across as super boring. So starting with number 10 here, consider these figures. Describe the steps that you would have to take before you could use the hypotenuse leg theorem to prove that these were congruent. So in order to use the hypotenuse leg theorem, of course, we need to know that our triangles are both right triangles. We know that this triangle is a right triangle, and here we could say, oh, I have this 114-degree angle. It has a 56-degree angle here, or sorry, a 66-degree angle, plus this 24 is 90. So we know they're both right triangles, so that's good. Then we would need to know that the hypotenuses were congruent. Well, we only know one hypotenuse, so one thing we would need to know is that this hypotenuse was congruent. We could find that out by doing the Pythagorean theorem. So that's the first step we would have to do, is you would need to use the Pythagorean theorem. To show that GJ equals 13. To show that GJ equals 13. And then related to what I said before, you would need to demonstrate that angle L is a right angle. You need to show that it's a right angle so that we can use the hypotenuses and the legs and the fact that they are right triangles to use the hypotenuse leg theorem. So to show that GJ is 13 and demonstrate that angle L equals 90 degrees. And then you could use hypotenuse leg theorem. Number 11, Mohammed wrote a paragraph proof to show that triangle DEG is congruent to triangle EFG. So he says the figure shows that they're right triangles, which is true. The figure shows that DE is congruent to EF, and EG is congruent to EG by the reflexive property. Therefore, by the hypotenuse leg theorem, triangle DEG is congruent to triangle EFG. EG, however, that happens to be the hypotenuse of triangle GDE, but it's not the hypotenuse of triangle EFG. So this leg being congruent to itself is not useful for showing that a leg, a hypotenuse, and a hypotenuse are congruent. So GE is the hypotenuse of one triangle, but a leg of the other. So there is not enough information to use the hypotenuse leg theorem. All right, for exercises 13 through 16, you are given a theorem and a congruent statement. What additional information is needed to prove the two triangles are congruent? So 13, if we want to use angle, side angle, we know these angles. We know AC is congruent to EF. So if we wanted to use angle, side angle, we would need another angle on the other side of that side. We would need to know this and this. So we would need to know that angle C is congruent to angle F in order to use angle, side angle with that information. What if we wanted to use angle, angle, side, and we were given that angle B is congruent to angle D? If angle B is congruent to angle D, we have two angles right next to each other, And to use angle, angle, side, we could either choose this short side is congruent to this short side, or this hypotenuse side is congruent to this hypotenuse side. Because as long as we don't choose the included side, the one in between the two angles, we can use either of the other two. So there's two conditions for this. Either we would need to learn that AC is congruent to EF, or we would need to know that BC is congruent to DF. We just need one or the other, not both. Then what about if we want to use side angle side, knowing that AB is congruent to DE? So if AB is congruent to DE, and we want to use side angle side, then the angle we have must be the included angle, and the other piece of information we need must be this side right here, AC, and this side right here, EF, to make this side angle side. So that would mean we need to know that AC is congruent to EF. And then finally, what if we want to use hypotenuse leg, and the information we know is that CB is congruent to DF. So that means that right now we know that these are two right triangles with congruent hypotenuses. We would either need to know that the short legs are congruent as well as the hypotenuses, or that the long legs are congruent as well as the hypotenuses. So this is another one where we could have two different information pieces that would work for this problem. So either we need to know that AC is congruent to EF, or we need to know that AB is congruent to DE. One or the other, we don't need both. Numbers 17 and 18, what information would be sufficient to show that the triangles are congruent by the hypotenuse leg theorem? So if we wanted to show that these two triangles were congruent by hypotenuse leg, we see that they are both right triangles, which is good. We have the hypotenuse of this triangle, but not the hypotenuse of this one. So we would need to know that HK also equals 15. And we have the leg of this triangle, but not the leg of this one. So we would also need to know that GL also equals 9. Then we could use hypotenuse leg to show that those were congruent. 18, we would need to know that, well, first of all, in 18, we don't have either hypotenuse. And in order to use hypotenuse leg, we need to know that the hypotenuses are congruent. So first, we would need to know that BC is congruent to DE. That's important. We have to have that. And then we could have one of two things. We could have another pair of legs. So after this, either we need to know that EF is also equal to 12, or that AB is also equal to 33. So we would need this piece of information and one or the other of these pieces of information to use hypotenuse leg. Number 25, which statement proves the triangles are congruent using the hypotenuse leg theorem? Well, right now we have two legs that are congruent. We have right triangles. So all we need to know is that the hypotenuses are congruent, and that is choice D. AC is congruent to DE. Numbers 19 and 20, we have to do some proofs. Write a proof using the hypotenuse leg theorem to show that the triangles are congruent. We've got some information already. These aren't too terrible, I don't think. So let's make some proofs. So of course, we have our given information statements that AB is congruent to CB, and that AC is perpendicular to DB. So of course that means we have right angles, and it means we have the congruences that are marked on the diagram. So that is given. Because we have those, we can state, and this is important, anytime that you have the information, there is the perpendicular, we need to change two angles being perpendicular into those angles being right angles. So we need to say, because this is perpendicular, then these are right triangles. So we can say that triangle BDA and triangle BDC are right triangles, because we need to know that they're right triangles in order to use the hypotenuse leg theorem. So it's important that that's in your proof somewhere. Okay, so that is because of the definition of perpendicular, creating right angles, which makes right triangles. So the definition of perpendicular. Once we know that those are right triangles, we also know that BD is congruent to BD by the reflexive property. BD, a leg, is congruent to BD, a leg, and that is by the reflexive property. Number 4 then, here, let me mark that in. Number 4, let's see. We want to prove that these triangles are congruent, and we have right triangles, we have the hypotenuse is congruent, and we have a pair of legs congruent. So we can say that triangle ABD is congruent to triangle CBD by the hypotenuse leg theorem. And that's all there is to it. We just need to know that they're right triangles. We need to know a pair of legs is congruent and the hypotenuse is also congruent. Number 20. Again, another proof. We want to prove the two triangles are congruent. Let's see. Okay, so we've got statements on this side, and we've got reasons on this side. So we'll start with statement number 1. We want to state the given information, right? That's in the diagram and up there. We know that EF is congruent to GH. We know that G is the midpoint of EJ. Okay, and we also know that the triangles are right triangles because that's given. So we can say, and I'll just put it in a separate step so it doesn't get too crowded. This is given, but also step 2, the triangles are right triangles. We need that in order to use the hypotenuse leg theorem. That is given because it's in the diagram. Number 3, because we have the midpoint of EJ, that means that EG is congruent to GJ, right? We know that since G is the midpoint, and the definition of midpoint tells us that those are congruent. So EG is congruent to GJ by the definition of midpoint. And now that we know all of these things, right? We know there's right triangles, we know that the hypotenuses are congruent and a pair of legs is congruent, then we can say that triangle EFG is congruent to triangle GHJ by the hypotenuse leg theorem. Almost done here. Number 22, Raul wants to verify that the steps built by a carpenter are uniform by checking that the triangles are congruent. The carpenter assures him that they are because AB is congruent to CD. Let's write that in. And BC is congruent to DE. So the carpenter says, well, my steps are the same height and they're the same depth, so the triangles must be congruent. A, explain why Raul cannot use the hypotenuse leg theorem to prove that those are congruent. Well, he can't use the hypotenuse leg theorem for a couple of reasons, but one of them specifically is because these aren't marked as right triangles. We don't have any information that would confirm to us that these are right triangles. They look like it, but we know we can't trust that in math. So we don't know that there are right triangles here, which means we can't use the hypotenuse leg theorem. So we can say, we don't know that these are right triangles. We don't know that these are right triangles because they are not labeled as such. They're not labeled as right triangles. B says, is there another theorem that Raoul can apply to prove that the triangles are congruent? If so, state the theorem. If not, explain why not. Well, right now, Raoul only has a side from one triangle and a side from the other triangle. So side, side. We don't have a side-side theorem. We need 3 pieces of information to prove that these two triangles are congruent, and not 2 pieces. And we don't have any other pieces of information. We don't know anything about the third side or any of these angles. So we cannot, okay? So we can say no. You need more information to use any theorems. No. You need more information to use any theorems. Number 24, match each set of congruent statements with a theorem that can be used to prove that the triangles are congruent. So once again, we are looking at what do the pieces or the information, what do they give us here? So let's do some drawing and erasing. So PQ, ST, QU, TR, sorry. So that gives us side angle side pretty clearly. So one is C. Then we can erase what we've got here. The next one is that PU is congruent to SR. And QU is congruent to TR. Since we have right angles, this is hypotenuse leg. That's D. The next one is that QU is equal to TR. And angle U is congruent to angle R. That gives us angle side angle congruence as we look at Q to U. So that's going to be A. And then, of course, that means the last one will be B. All right, if you've got any questions at all, let me know. That's the end of this worksheet. And have a wonderful day.